we've reached the final panel of the day, and you'll be glad you stuck around for this one. Here to moderate this panel is Captain Scotty Hammond, who is the ALPA Central Air Safety Chairman for Delta Airlines. Thank you, Scotty, and we look forward to hearing from you and your distinguished panel. It's all yours.
Thanks, Steve. This panel is going to be run just a little bit differently. We've had a great day. Anybody that's interested in human factors, you just can't help but enjoy a day like this. But this panel we're going to run a little bit more informally. I'm going to dispense with the prepared remarks that I had and launch a little bit more quickly into a panel discussion. I think that you'll appreciate it. It would be a waste of our expertise if we didn't do that. Along those lines, I want you to start thinking about your questions early, because I would like to get into audience participation Q&A a little bit earlier as well. By way of setting the panel up, given a couple of the things that I've heard earlier today, I was thunderstruck by two things. The first was by the comments that Robert Sumwalt made, but especially his slide where he showed his objectives and questions from 18 years ago when he ran a very similar exercise to this, and it could have been written yesterday for this panel. Now, at the break after that, I heard someone say, well, obviously we haven't come very far, we haven't done very much if we're still asking the same questions. I would actually turn that comment on its ear and say, no, it probably means we're asking precisely the right questions, because I would expect that we will be asking these precisely same questions in 2036 if we're doing our job right. There's never going to be a complete answer or a complete solution to any of these things, but we need to be asking the questions in order to move the industry forward. The other comment that I was just completely taken back by was the observation that our culture in the industry is changing underneath our feet. Now, that's something that is a theme I think most of us have recognized for a few years. We've got a lot of people that are being hired, a lot of people that are retiring, so we know that this cultural change is occurring. But the observation was that we've been the beneficiary of such a stable and experienced pilot force for so long that we've probably grown really, really comfortable and accustomed to that. And when we think about it for a minute, we know beyond a shadow of a doubt that that is not going to be the case in the industry just a few years from now. In fact, it's not even the case right now. It's changing underneath our feet. Automation exceptions, the new unusual attitude, was a theme that I picked several months ago before we knew who the panelists would be and exactly when we would be going during the day and what we wanted to cover. The reason why I chose this terminology is because from my own experience and then also from observations from ASAP and FOQDAT, it's occurred to me that the classic way that we have learned to fly, close your eyes, upset, recover, that all of us experienced, while still applicable, is just not the unusual attitude that we're recovering from normally anymore. The far more common upset state that we see through ASAP data and FOQA data is as a result of an automation exception, and not necessarily because an airplane mode has failed, but because we have either misprogrammed it or we don't understand what the automation is doing to us now, and the aircraft is deviating from what we expected. And the thing that really concerns me about this when I look at our data is some explanation about why then it takes so long for the pilots to intervene and correct this undesirable state that is evolving. Bobby Wells maybe gave us some insight into that when she talked about startle and surprise and complacency, and maybe one of those, or maybe all of those in combination, are the primary drivers behind why we see automation taking our airplanes in a direction that we did not intend, and then a lengthy delay sometimes before we actually intervene and regain control of the airplane and put it back where we want it. As our panel was developing, and we knew who the panelists would be, I asked for each of them, and I would ask you guys to consider the same thing as you start to think about formulating your own questions, is to try and answer these three questions. The first is, what do we understand about human factors today in 2018 that we didn't understand 2 decades ago? What has changed there, if anything, and if our understanding has changed, should that be informing the way that we train airplanes today in ways that are maybe somewhat different than the way we were training crews when they were coming on to these glass airplanes 20 years ago, when the glass was brand new and the pilots were old analog guys? So that would be question number one that I would want to think about. Question number two is, what are the emerging technologies that we can be expecting that's going to affect the way we fly our airplanes with the automation that's coming on? Laura Edwards gave us a little bit of a peek under the tent with her description of the A350. We're fortunate that we'll have some Boeing insight from our panelists today as well. And I think that as a group, we really need to think hard about this to try and figure out where we're going. And then maybe most exciting of all would be, what do we need to be thinking about from a human factor standpoint in 2018 to turn the problems that are coming our way with all of these changes? We know that technology is rapidly changing, and Moore's law tells us that it's changing at an ever-increasing exponential rate. We know that that is the world we live in. So what do we need to be thinking about now with this new generation of pilots that are come rolling in to make sure that they're adequately equipped to deal with the changes that they're going to encounter for certain over the course of their career? I'm really pleased to introduce a spectacular panel with great cross-section of perspective. We have Shayne Daku from the University of North Dakota, who is an assistant professor and experienced with training the new generation of pilots with the airplanes that they have up there. We have Mark Nikolic, who will give us some perspective on new technology with respect to automation that is brewing over in Boeing. He's experienced with touch screen displays. He's a human factors engineer with cockpit displays as a primary focus, which is just part and parcel of what we as pilots have to wrestle with when we're dealing with automation. We have Dr. Amy Pritchett, department head at Penn State for aerospace engineering, who has also had some experience with her association at NASA before that, and through some of her studies, to give some really deep thought into where automation is going beyond these changes that we are expecting to see with the next generation of airplanes, A350, 777, and so on. And then lastly, we have Captain Mark McCullins from Airbus, chief test pilot for Airbus at the United States manufacturing facility, who has also given some significant thought to what automation needs to look like in the future based on artificial intelligence, and then also the implications for society, what we are and are not prepared to deal with in that respect, and then also some of the liability and legal concerns that the corporations are going to have to deal with as we move into this brave new world. So if you think about formulating your questions here shortly, what I'm really trying to do is frame this so that we look at what's going on today, and then also look out far enough to where a 23-year-old that's coming on to a Part 121 operation right now will see over the trajectory of their career before they retire. With that, I want to shift right into a conversation with each of our panelists here with a specific focus on their area of expertise. Shayne, with your regular interaction at the University of North Dakota, Help us to understand what the airplanes that you're using look like and the automation that you're using looks like. I suspect it's significantly different than the tailwheel airplane with no radio that I learned in.
Yeah. Well, first of all, it's a great honor to be here. Just even as a spectator, I'm learning more. Our industry has seen in the general aviation side and within flight education a revolutionary change over the last 5 years even. So we have 130 approximately aircraft, three of which have conventional instruments. All the remaining are glass, including our helicopters. We're having aircraft delivered this week. In fact, 5 of them are being delivered from Vero Beach to Grand Forks, North Dakota, 18-hour trip. They have G1000, 15-inch panels, 2 of them. Standby instruments are an Aspen 2x6-inch flight display, no traditional instruments. Probably when I sat in one of these for the first time, the most jarring change is there's no magnetic compass, which was I guess one of those things that I sat there for a minute and said, well, I guess we don't need one of those anymore. And continue to scratch my head on that one, but apparently the compass is enough of a weight and expense that we don't need to add those to the airplane. So we have a pretty nice view out the window now without the compass there, and I would say that view is very, not used maybe as much now that so much information is placed on the displays. And so that's why for me, being here and learning all of what you've learned over the last 2-3 decades of working with glass airplanes and training pilots in glass airplanes, that's where I think for myself, we've had a lot to learn, and we've had a lot to glean from industries that have already been through this. One of our initial challenges was, how do you take a private pilot applicant who has never seen an airplane before and put them in a Cessna 172 with the G1000 panel, and then tell them to focus on their crosswind correction or their crosswind correction during taxi, or even tell them how to taxi. They could look right on the multifunction display and taxi without looking outside completely. Synthetic vision has pretty much allowed that to happen. So how do we take something that's got that level of technology and force them to embrace the fundamentals? Not only that, but they're being instructed by 19, 20, and 21-year-old pilots, flight instructors, who have, for the most part, not experienced life in a traditional instrument environment. So it's been a challenge, and it's been one that we've, I would say, embraced. We've used a variety of policy, basically, for lack of a better term, trial and error in some cases, to come up with a system that works currently. I will say, I delivered a brand new Seminole, Piper Seminole, last summer, and it had G1000 dual panels. It has an autopilot system that I hadn't seen this button since I was in the airlines, but an FLC button. So there's flight level change in a Seminole now. We have the capability of flying everything but the RNP approaches. The GPS WAS capability, hold entries are all predetermined. LPV approach procedures are all done inside the G1000. So there's a challenge that we've gained a lot of components. We've gained a lot of systems that require more cognitive pieces, but we haven't really lost anything. I just finished teaching an instrument ground school where I spent a week teaching the functions of a basic gyroscope, precession, rigidity in space, talking about components that are still in the ACS and things that we still need to discuss but are not in the particular aircraft that they fly. And I had a student in the back raise his hand and ask, will I ever need to know this precession and gyroscopic, these gyroscopic principles? And I was after about a 2 seconds of, luckily I can think quickly on my feet. This is one of those concepts, this is one of these problems that we're faced with day in and day out. Now, not only do we have a generation of pilots that question a lot of things, and that's a good thing, but they question things that we've done for years, and they've questioned it in a way that makes us certainly seem like maybe we should ask the question for ourselves too. Is there content that we can remove, and is there content that needs to be there? And so a lot of our focus is shifting into what these panels and this discussion is all about, and that's the human factor side, making decisions. Where does the automation take us? Because now the automation, for a long time, we didn't have automation that could take us places. It was called trim. That was the automation that we had before. But now the automation can take us to 200 feet above the ground and leave us there. And the decisions have to be made.
In many ways, we see that general aviation is more agile, more nimble in adapting and adopting new technology. But there's a reason for that, because we who fly in Part 121 operations recognize that there is an enormous value in consistency and stability in what we go out and fly, so that we don't have to continually adapt to change every other day. Mark, you're looking at the next generation of changes that we're going to see in displays, and I'm sure you're also cognizant of hanging on to the things that are habit patterns that we don't want to get rid of. Tell us a little bit about what we can expect to see with Boeing, and especially I think the audience is going to be interested in touchscreen.
Yeah, thank you. Well, so first of all, I wanted to thank you all for staying here this afternoon and hearing us speak, and thank you to ALPA for having me here. I think being a human factors practitioner in flight deck design and getting a chance to talk directly to our users is really invaluable for us. So the discussions have been great, and I hope we keep the dialogue going. So I've been at Boeing for about 13 years now, working both in R&D and in the displays group, some of that with Barbara Holder, actually. I would say that over that time period, my focus has shifted from working on designing the feedback from the automation to designing how pilots interact, or redesigning how pilots interact with the automation. And why is that? So I think fundamentally what we've been seeing is a gradual increase to more displays, more display-based functions, larger displays. And we alluded this morning to the ubiquity of EFB, tablet-based EFBs. And so there's just a lot more to do on the displays today than there have been in the past. And the challenge is really, or one of the new challenges is getting around those displays, getting to the functions that you need to do and perform. And so, we've seen this evolution, and certainly we've seen it at Boeing, where we had, some basic interactive displays on a 777. And then if you've seen that evolution from a 787, where we're interacting with displays using a cursor control device, but now it's over multiple multifunction displays. And I really like to think of it as an extended desktop, right, where you're having to move a cursor around. And I think we see the same thing on the A350 as well, as we alluded to earlier today. So, during this time that I've been there, we were having to think about what the next new flight deck was going to look like after the 787. Problem is that the 787 wasn't in service yet, so we didn't have a whole bunch of ALPA folks to ask, hey, how's it going on the 787? So our team internally did some human factor studies. Part of that is some survey work that we did. And so we went ahead and asked the Boeing pilots, the 787 pilots, about how things were going on the 787 during the test program. And one of the first hints that we got that we actually needed to evolve something about the interface was that we got about 80% of the citations in the survey were about interacting with a display-based CDU, or the flight management system. Okay, so now that the flight management system is on a display, it requires the cursor to move around it. So it's a bit less direct than the hardware keypad before. And then the second clue that we got was once pilots actually started getting in the sim for the 8.7, and especially for the first time, we would just see them go straight to the displays and touch them because they look like they are interactive buttons on the displays, and we're all highly familiar with the phone technology and the tablet technology that we have. It's compounded by the fact that we have touchscreen flat panel trainers for the airplane. So that already gets you into a mode of touch interaction. And then we also had Class 3 EFPs at the time installed. So you had this mixed mode of interaction where you were touching on the side, but once you got to the main displays, you couldn't do that. So, you know, we really thought, you know, we need to make that change for the 777X. And so that's really what I've been working on for the past 8 years now is the research and development involved in getting touch displays onto the 777X for EIS, which obviously includes all the human factors, data collection and analysis that we would do for usability and motion, things like the fingerprints and failure modes, et cetera. So, so that's what I've been working on, and that's what's pretty much coming down the pike for the 777X. The nice thing about just this technology is, and we've talked a little bit about the sea change that's happening in the pilot population. And we've been finding that interacting with displays directly using touch is very cross-generational. So it's not just, you know, the younger pilots that are familiar with it, but it's, you know, mid-career, end-of-career pilots as well. Yep.
We're going to shift gears for a second. You know, it's almost like there's a bright line between these two guys and those two guys, because what I would like for us all collectively to do for a few minutes is to dispense with everything that's happened up until now in the world and start thinking about what's coming our way. One of Dr. Pritchett's comments that we've heard mentioned earlier today in another way is that just because we can do something doesn't necessarily mean that we should be doing it. Amy, could you give us a little bit of insight just from a deep thought standpoint about what your experience and research has shown about pilots in the loop and increasing levels of automation? Sure.
Indeed, thinking about driving here today, coming up towards the panel, I had a couple thoughts, and I think I'll put them on a timeline. 80 years ago, even 100 years ago, when we talked about the pilot in the loop, meaning a manual control issue, I will point out that they very quickly start evolving to manual control standards, handling qualities, flying qualities for the vehicle, that they said this vehicle needs to be easy to fly. And if a vehicle was hard to fly, as they moved into vehicles, World War II, fighter jets, and so forth, they quickly came up with handling qualities where if the vehicle was hard to control, it was on the vehicle, not on the pilot. You didn't blame a pilot for a pilot-involved oscillation with a vehicle that was hard to control. I will contrast that 80-year observation with automation. Look at a CVR where the last thing the pilot says is, make it stop, or why is it doing that? And we go, bad pilot, posthumously. You should have figured it out. And so why we do not have the same attitude to a vehicle that is hard to figure out the decision loop, the alerting loop, the communication loop, as compared to a vehicle that is hard to control in the control loop, is something that I think we need to work on. We need to have pilots stand up and say, this is unfair. If I can't figure it out, please don't just tell me, who's been reading the manuals, bad pilot. So that's one historical observation, is comparing what we're talking about now with where automation pushes us out to making decisions about the decisions that the AI is going to make about the control, is at some level unfair, and we should push back on. Now, another thing you had specifically mentioned 20 years ago. My perception of 20 years ago is we used to hear a lot, especially from the technologists, that with this new automation, the pilot will just be a supervisor, a manager. And 20 years ago, we made it seem like this was a good thing. Now, by the way, 22 years ago, The Simpsons released a very prescient episode called Maximum Overdrive about a automatic truck driving, where the truck driver said, with this new Navitron system, all you have to do is sit back and feel your ass grow. Excuse me for my French, just a direct quote. And we used to think that was a good thing. 20 years ago, we used to say, hey, being a manager sounds pretty good. Well, I'm now not just a manager of people, I'm also the mother of a teenager who often acts like an idiot savant, which is what automation acts like, right? If you are not supervising said idiot savant automation closely, it will do the same mistake over and over and over. And it turns out it is hard to be a supervisor. You sit there and you wonder, why is it doing that? Is it supposed to do that? Is this a good thing that I'm just not tracking? Or is this a bad thing? Should I intervene? Should I give it another minute? This has been named in multiple domains. The problem of monitoring and intervention in a supervisory context is a problem in multiple domains. I've heard the same thing in air traffic. When you have a trainee controller on scope with a certified professional controller, a CPC supervising, you have more operational errors. Even though you have a CPC sitting there watching, that CPC will take a long time to go, should I step in? Should I step in? Is this the right time to step in? In that case, you don't want to step in too soon because your trainee never gets trained. In the case of automation, we're telling pilots often, hey, this is automation. It's doing the right thing. Use it. It's more efficient, better fuel efficiency, new arrivals, continuous descent approaches, whatever the latest buzzword is that we say in automation. And you sit there and go, why is it doing that? Does it make sense? What am I missing? It's really hard to be a manager. And so 20 years ago, where we made it sound like being a manager or a supervisor was a good thing, I would like us to see turning the corner in that dialogue to say, you know, being a supervisor is really hard. So now, so where are we going with this? I'm married to a UAV designer. And so I will be working in the kitchen in front of an open window, and a drone will come up right in front of me. And I'll hear, honey, look at this, what I got it to do. I need to go put this on my production vehicle. And I'm like, why? That looks insanely hard to supervise. I don't know when you're going to use it. It's going to add more complexity to the system. It's going to add another failure mode. This is safety person married to UAV designer. It's a happy marriage. And with that then is the question of, I know from working with aerospace engineers, my department, my husband, my discipline, that there's a lot of enthusiasm for so many technical capabilities we can bring. But I would like to see us add, and Barbara was mentioning before, what is it pilots do? Are we really automating the right thing? I've proposed to aerospace engineers, how about you stop trying to push the pilot away from the control loop? Why not give the pilot the control loop and automate everything else? And they go, oh, well, that's too hard. We don't know how it's done. And so we're really letting them take over the easy part of the task. I worry about that.
Thanks, Amy. So Captain McCullins, Truth in Advertising, I've seen part of your presentation before, and I can't think of a better panelist to sum up the day before we jump into the Q&A. Help us to understand some of these ethical implications that we're talking about.
Well, it's funny, the three slides I have really do follow on, if I can get the first one up here. Is to answer the question, what exactly is it that we're automating, and where are we going with this? Because on one side, we look at our new aircraft, and they seem to be incredibly automated. When you look at this taxonomy of automation beside me, we're sitting at level 1. We have all kinds of systems that we have to program, we have to interact with, to do jobs with us, that we have to supervise. But are they really helping us? Are they helping us make decisions? Because what is actually the role of the pilot today? And I'll get to that in a second. But why do we need to move up this level of autonomy? Well, you heard about the A350 and some of the things with 787. And what we've done is we've taken one way to interface with an aircraft, and now we've given you 5 ways to interface with the aircraft. In 1952, Hick's Law. This didn't actually come from an aerospace textbook. It came from a technical diving textbook. And you're not getting out of here without a math equation at 4:30 in the afternoon. But all you need to take away from this is that the reaction time of an operator to a problem is not linear. If I give you 2 solutions to a problem, it doesn't take you twice as long to decide which one to use, or 3 or 4. It in fact takes you an exponentially longer time. So why do we need to move up this level of automation? Is because we need to start to give our crews, our pilots, decision support to reduce the number of decisions that they have to make, while at the same time being transparent about how we came to that. So in giving us some thought, what I wanted to do in a paper I wrote was to inform the conversation that we have to have about where we're going. And I thought about Asimov's laws of robotics, and I thought about the Prime Directive, a lot of these sort of science fiction, because it's been imagined. What are some basic levels of principle that we should have as a community of pilots and designers to talk about the next generation? So we came up with what I call CALI principle. 4 letters designed to let us break down these advanced systems and give us basic principles that we should look for. And I find myself using this now when I see a story about a self-driving car with issues or a train accident or something. I find myself now starting to break this down. And the first one I have, going back to the very first comments that were made this morning, is keeping humans in the loop. As we progress into highly automated systems, as we progress into artificial intelligence, the one thing that we must very jealously guard is keeping humans in the loop. This is not a technical restriction. This is a moral and ethical imperative. Because there is no system today that can take a moral decision on what we should do under duress. There is nobody ever conceived of a drone that would land in the Hudson because it had double engine failure. So as I wrote my paper and I researched this, and you start to get into principles of consent, principles of how do we apply technology in a society, I had to ask myself, what is it that the captain does? Why is the captain still on the aircraft? And the answer I ended up coming up with is the captain is there to make ethical assumption of risk on behalf of the passengers, the aircraft, and the people underneath it. So in that sense, when we look at AI and autonomous operations, it doesn't much matter to me if it's a cargo drone, if it's a 747, if it's an A380. There has to be somebody in the decision-making loop that is making that decision on an ethical basis. Hence the first letter, K, keeping people in the loop. The next, the A, was for augmented decision-making. And you need augmented decision-making as the systems get more complex, as we start to look at aerospace, not just aviation systems. We need to somehow narrow down the number of choices that the crews have to make. And that's where it gets into this progression of automation that I was talking about. And one of the comments, I've heard it here today, I heard it at the FedEx conference, is we'll deal with engine failures and dual hydraulic failures, but please don't give me a runway change. Well, this is the sort of augmentation we're talking about. Hey Siri, hey Callie, change me to runway 8 left. Now, I have to give you a little bit of full disclosure here. We chose the acronym Kali. It's the Hindu goddess of rebirth. It's also what we happen to call my 5-year-old daughter, Kalindi. She's 5, so when I say, hey Kali, I expect neither compliance nor a consistent result, which is a wonderful place to start with artificial intelligence. The third part of this principle is, and I feel quite strongly about this one, is local primacy of execution. When you have an aerospace system, we should not be making decisions 5,000 miles away from a remote control room. And we could talk at length about risk homeostasis and reasons for that. But part and package of keeping humans in the loop is keeping humans with humans. And it's funny, when we talk about would you get on an airliner with no pilot, everybody kind of goes, you get that feeling sort of between your, on your back. And there's a reason for that. It's because it's ethically not how we're wired. I think we can all agree that the person who makes decisions that accept risk on behalf of the aircraft should not have been the programmer in the room 10 years ago. Right? We're all prisoners of our own experience. A non-adaptive system is a prisoner of the programmer's experience when it was written. Now, this will change. It's changing as we speak. But again, the idea here was to give sort of 4 principles that would allow us to evaluate that change. And the last one, integrity of communication. This would have been a very different discussion 5 years ago when we looked at bandwidth available, satellite communications, you look at what happened with Malaysian Airlines. Integrity of communications now becomes a fundamental enabler for these advanced systems. You know, as I envision what we want to see 20 years from now, it looks a lot like Apollo in the 70s. It means when I have a problem over the North Atlantic, I'm not alone. I maybe have a virtual co-pilot. I maybe have a second pilot with me. We have a control room manned by a pilot or a controller who has a mission control behind him or her with specialists. And there's all kinds of ways you can leverage the technology. And my idea in presenting this was not to say, this is how we're going, but rather to sort of help inform industry and the audience how we can start to slice and dice these conversations so when people come up to us and say, I think we should want to go all electronic QRHs. Well, in fact, you can start to use these sort of 4 guiding principles that have a ethical as opposed to a technological basis and begin to answer those questions and have a discussion.
See why I wanted to make sure that we left plenty of time for audience participation. Anyone that has a question, please step to the mic right now. While we're waiting, lightning round. I'll ask you guys questions. You only get 30 seconds to answer. So I was asking you about millennials, and are they really that much different? You said, no, it's Generation Z, which makes this 64-year-old head hurt. What's Generation Z?
Generation Z is currently in college. They're from 1997, born from 1997 to 2010. And they are digital natives. They've grown up with technology in their hands.
Excellent. Mark, promise me that you're doing HF on how I'm going to do touchscreen and turbulence.
Oh, for sure, yeah. I mean, we've actually flight tested already, and that has resulted in designs for the physical bezel around the display to aid with bracing and those issues. But we have redundant controls as well, so it's not just up to the touchscreen. It's a suite of display interaction controls that are available.
Amy, you talked about us demanding and expecting more consistency and automation going forward in our interaction. Would you say that this is primarily a regulator function, or should it be industry-driven?
Well, if it's not a regulator function, it'll become a litigative function. It already is.
Yeah.
There's numerous accidents where after the NTSB report is out, it moves to court, and you say, how could you blame the pilot or the airline for something where there was no way that a reasonable person in that context could have handled it?
Yeah.
So we're already seeing that in the courts. I do believe that instead it needs to be a mind shift in the industry that is then reflected in the regulations more.
Mark, do you think that there's anything for the aviation industry to learn from what self-driving cars are going through right now with respect to litigation, accidents, and all of the societal implications?
Oh, absolutely. And sorry, if you can throw the last slide back up for me again. I first did a presentation on this 3 months ago. Between my first and second presentation, I added 3 slides on self-driving cars. And I started to slice and dice it with this. You know, the issue that you see, for example, some of the Teslas, keeping the human in the loop. Now that happens to be the control loop. And we can all talk about how effective or not effective that is. Helping them make a decision.
Amy.
And I'll, just Agreeing with you, I'll add that if you look at the NISTA report to the first fatal Tesla accident, they blamed the driver for not supervising the automation closely enough. They note that there's a long list in fine print in the driver operation manual that lists when the automation should not be used, and that it was the driver's fault for not knowing to disconnect fast enough.
Yeah.
And you know what? If we were really helping the driver, at some point, the car would have a chat with them. And I don't mean beep, beep, beep. I mean, we've disengaged your system, press this button, and we'll tell you why. And it's funny, we had, at Society Experimental Test Pilot last year, we had a presentation by Dr. Kathy Abbott. And she was actually the person who inspired me to start this research. And she said, we need to understand why the systems make the decisions they do. Now, there's a fine line between hobbling your system by making it explain everything and then just letting it go. But it's something maybe that we could be doing better, is at a certain point, when you go, why is it doing what it's doing? There should be an opportunity to have that answered by the system.
Sam, what's up?
Thank you, Scotty. Sam Miller from MITRE. Amy, you are a person after my own heart. If you ever need a cheerleader when you're arguing your case, I'm your guy. So, thank you. Scotty, for the group, there are a lot of, has been written about generational differences today and for the technology, and as we kind of touched upon earlier, I'd like the panel's thoughts. Are we designing and building airplanes today going forward technology-wise because we can, or do we really have that generation in mind in the design?
Great question, Sam. And you know, before I tee this up for you guys, I guess I should share with you my experience, which is probably similar to a lot of people in the room. When we learned to fly automated airplanes, we were coming off of analog airplanes, and so the technique was you have to do all the automation all the time. We know you can turn the automation off and revert this Airbus back into a Boeing 727, but we're not going to let you because we're going to force feed you into the automated age. I suspect that your problem is exactly the opposite, Shayne, because now what you've got are not guys that have any predisposition to manual flying, but are exposed to the automation from the get-go.
Yeah, absolutely. Yeah. One of the challenges with generational discussions is they become negative very quickly because we view our generation as the smartest, the best, the only generation, and that's not the case, unfortunately. Sorry to break it to you. But one of the challenges we find is that there's a lot of preferences, there's a lot of foundations that come with a generation, but that doesn't mean that's the only way. It doesn't mean that's the best way. But we need to understand where you know, a student is coming from, what they perceive, how they perceive, and then be able to go from there to where they need to be. And so that's where, I guess that's what makes my job interesting, challenging.
And somebody raise their hand if they've got an answer, because maybe this is generational, and maybe this is just me. But when you start describing the ability to do one thing 4 or 5 or 6 different ways, I want to scream out, just give me a way that will work all the time, that is robust, bulletproof. I only want to know one because I've got limited bandwidth to absorb all of the other things that you're trying to teach me. Is that generational, or do you think that, can we expect Generation Z to be much more agile than I am?
No, I think that's
I know we can.
Yeah, no, I think that's fundamentally true, that sometimes fewer options are better than too many options. I think you start getting into a lot of cognitive overhead in terms of using the interface once you introduce way too many options to do one thing, and that's feedback that we've heard as well. I think early on, the design intent, back when the glass cockpit systems and the large display systems were developed, was to provide maximum flexibility, because that was really what was valued at the time. And I think now, over time, with some experience, I think understanding that having too much flexibility can have a cost. And, yeah.
And also, I think it's easy to confuse the task with the tool. that we're giving them 4 or 5 different ways to do the same task. The question is, do they understand what is that underlying task? I know of periods of fascination when I understood why the air traffic control system was put together the way it was, why the entry onto an ILS is a teardrop if you're coming from this direction and a direct intercept if you're coming from that. And that was an understanding of tasks that these days it's easy to press a button and have it happen, but in doing so, the task to them may appear to be press the button and not what's the underlying dynamic that you want to have happen. So keeping some focus on what it is you're trying to have happen, why having all these different options gives you power, but only if you understand what you're trying to accomplish is important. But like you said, first you have to understand one way to do the task and do it well before you can start seeing different options and really using them cogently.
What about today's generation of students, which I hear are different than my generation from the standpoint that they just want to know where to look information up. And as long as they can do that, they're happy. They don't need, they're not interested in understanding. They just want to be able to get the answer and move on to the next thing. Mark?
I don't think that's entirely fair. I think they do want to understand, but the method, the schema that they're using to access that information is different and possibly more efficient. When you look at the evolution of training, I think it's generally accepted today that we want to let people learn and absorb information on their own terms. Now, that makes it for the instructional designer a lot more challenging because, for example, when I look at the Airbus cockpit environment for the 350, there's 3 sets of controls on how that you can access it, one of which happens to be exactly the same as if you were playing Call of Duty. There's gamer controls, there's regular controls, there's an alternate set. We don't spend a lot of time saying, here's the 3, here's how they work. It's you choose one that works for you to access the information, and now we're going to get on with learning the information. So I think sometimes it seems complicated in the face of it, but when you focus on the task, then you become very agnostic to how they access that information, but it is a different way to learn.
Thanks. Brian?
Hi, guys. I have 2 questions. One's retrospective and the other's prospective as far as where we're going here. And Shayne, it's, I'm kind of actually probably, this is something Dennis Landry would ask, so you're welcome. As far as automation exceptions go, most of the people who started just flying needles and raw data really built up in their primary years a base of skill set, which, as we all know, once you move on to the more advanced aircraft, that's not as much utilized. But when you do have automation exceptions, and which I have experienced certainly in my career, it makes it extremely easy to fall back to my most basic mode of just flying the airplane. And if, on the other hand, you at those primary years are giving them much heavier aids and not as much just, you know, raw data flying, are we missing something when that happens, when you have 2 people now who really don't have a lot strong, you know, stick and rudder skill set?
I believe we are, and it's one of the challenges that we've faced. Too many of our discussions post-act, we have flight data monitoring, so we track everything that goes on with a Cessna 172. We know the cylinder temperatures for, you know, from start to finish. We track, you know, we do a lot of flight data monitoring, and that's the discussion that comes out of just about every one of our event discussions, or just a broad discussion, is let's get back to the basics. Let's go back to the basics on this. And so now one of the challenges is the basics of stick and rudder skills. We still have control over that. We still have manual power levers and prop controls and mixture controls. So we still have some basics, but the stick and rudder skills, we're very cognizant that we don't mess with that part of it. The challenge is we don't even have a magnetic compass anymore. So when you want to go back to, just point the airplane in this direction, we don't have a reference to that. So one of the things we're grappling with is with what we have, what can we train and what can we focus on? And so our focus has been on, we got the Cessna 172s, the G1000 Cessna 172s, and we found one of the biggest challenges we had a lot of accidents. And you'll say, oh, great, wonderful. And the accidents were students landing too fast, about 5 knots too fast, and ended up touching the nose wheel first, which bent the firewall, which resulted in an accident. And so those problems forced us back to fundamentals of flight, right? Trim, airspeed control, final approach control. And I think that's where we've spent a lot of our focus. But we have a small group that says, let's pay whatever we need to pay to keep those 3 conventional instrument aircraft around so that we can at least teach those fundamentals. And with 1,800 students and just under 1,000 of them on the flight schedule every semester, 3 airplanes is not going to cover it. And so that's one of the challenges that I think, maybe the philosophy is we train with what we have and use computer-based instructional models to train the other systems. We don't have a full solution to that yet. But.
We've talked about this deep into the night on a number of occasions. A couple of observations I would make. If I were king for a day, I would have a tailwheel airplane and a glider and a gyrocopter and a hot air balloon at every flight school, so that once a pilot learned basic tasks in whatever airplane he was flying, he would move on to the next and the next and the next, to build as wide a base of situation awareness as possible at the primary level that will stick with him or her for the rest of their career. The other thing that I would mention, and I'm certain that Delta is not alone in this, is that we oftentimes convince ourselves that just turning off the autopilot and following the flight director is getting at manual flying. And all we're really doing then is just muscle memory to follow the flight director. And we see over and over and over again that to get to the meat of the problem, you've got to turn all of the automation off so that you are actually looking at pitch and power and also accustoming yourself to what the automation looks like as you strip the automation away and then practice putting the automation back. Another comment that I found interesting earlier today was that because the simulators have become such primacy, I think I heard today that we need to practice on the airplane to prepare for the sim. Did anybody hear that comment? I know that's what I do, and so that is a complete inversion of the way we think of simulator and aircraft operations, and yet it's becoming a more and more pervasive thought. And I'm not saying it's wrong, I'm just saying it's happening. What do we do every day on the line to make sure that we're maintaining a relative level of proficiency?
Cool. And the other short question I have is, Mark, as you were talking about levels of automation and especially AI, the only thing that was just going over my head was, open the pad day doors, Hal. I'm sorry, Dave, I can't do that. And I'm thinking about we build these envelopes and getting to the point where we think we've thought through everything and the system isn't, maybe removes some of those, some of the authority that we thought we had, and here we are, what do we do now?
Have a look at my Cali model, think about 2001, and you'll see some interesting things fall out of it. You can almost use it on each one of the letters to rank and compare different solutions against each other, but I had that exact thought. Okay. And if he had have had local execution, he'd have been fine.
Dr. Barshi, I can't think of anyone in the room that I would rather have asking the last question of the day. And I don't even know what to...
Hate to disappoint you, Scotty. I don't have a question, I have a quick story to tell. We did the study after Colgan and Air France 447. There was a lot in the media about pilots losing their manual flying skills. And because of all the automations, pilots are forgetting how to fly. So we brought pilots to our 747-400 full motion simulator and put them in two kinds of situations, either a typical training situation or a typical line situation. So you know from the training that when the instructor behind you starts acting like the air traffic controller and there is a truck somewhere on the taxiway, you know it's going to be a go-around, right? Or if the wind shear alert comes on, you know it's a wind shear escape maneuver. Or if the instructor says, okay, level off at 5,000 and show me a stall recovery. You can show a stall recovery. On the line, unfortunately, there's not always an instructor on the jump set that says all these things for you, right? The bottom line of what we found is pilots have no problems with their manual flying skills in the typical training environment, in the typical training situation. But they do have a problem when they're not expecting something. Mm-hmm. And my conclusion from that study was that it's not that pilots are losing their manual flying skills, they're losing their manual thinking skills. They're not recognizing the situations. Once they recognize the situation correctly, they have no problem responding properly. So,
and that's one of the, there was an excellent research group that was, that gave a paper last year. When we talk about augmentation on the flight deck, that's got to be one of the prime roles of that, is helping recognize in an incredibly complex situation. And they used, for example, the Air Transat out of fuel in the Azores and the Columbia accident as examples, where you can have a system monitoring multiple disparate things that can start to piece things together quicker than the human and tell the human, you have an issue with your fuel system, here's what I recommend. And I think that's very much where we have to go with automation and augmentation, not another layer of approach capability.
And I'm agreeing with you, Emmanuel. I think that we tend to talk about a loss of manual flying skills being a problem with being able to fly the airplane. But I return to my own thoughts on monitoring. It's hard to monitor someone when you aren't current in their task. It's hard to monitor the automation flying the airplane when you have been losing that constant awareness of what the displays look like when you're flying the airplane. And so we're not just making the post-intervention part harder, we're making it so that you lose that sense of this doesn't look right. So pushing the pilot away from flying the airplane also degrades their ability to monitor, instead of just focusing on the post-recovery events.
And just one quick comment about learning to recognize can be done with mental simulation. It does not require a full motion, full flight simulator that costs a lot of money. Thank you.
So left to our own devices, we'd sit here till 8 o'clock tonight talking about this, and then we would go out to dinner and talk about it some more. That's exactly what I'm going to do anyway. But for everyone else, we need to wrap it up. I've got two quick things. It'll take me less than a minute. The first is shameless ALPA political plug for two pilots. I'd be remiss if I didn't mention that I began my training on a three-person airplane, 727. I fly a two-person airplane now. And I have extensive time in single-seat fighters. And I can tell you beyond a shadow of a doubt that when things are going wrong and I'm having a bad day, 3 is better than 2 is better than 1. So I absolutely think that collectively as an industry, we have got to be absolutely certain about what we're doing before we take the next step. Going from 3 to 2 is a pretty big step. Going from 2 to 1 is a gigantic leap by comparison. And then lastly, my biggest regret is that we didn't have 100,000 pilots that could have shared today with this conversation, as well as the designers and the rest of the industry. I commend everyone that hung in through the day today. Please go out and spread the word. And I think that we should all collectively take on the challenge of how do we take what what we've gleaned from the discussion today and spread it to the far corners of the industry. If we're able to do that, today will have absolutely been a transformative one that we'll all think back on and say, hey, I was there that day. Thanks, guys, and thanks to the panel.